Yeah, exactly.
For psychedelic and consciousness research, and I realized the original title of my talk was that it was the acute and enduring effects of hallucinogenic drugs on brain function and cognition. I'll still be going over all that, but I'm going to be framing it under what makes psychedelic drugs unique. And so, before I begin, by the way, can everybody hear me? Is that good? Yep? No? Oh! Let's see if I can, yeah, let me see. I think it's all the way. Let me see if I can, does this one also go up? Nope, they're paired. Maybe I can just get this closer to my face.
And closer to them.
Yeah.
Watch your foot.
Whoop.
Yeah. Alright, maybe that will help.
Maybe it's because of the way it's here. Is this any better? Yeah?
We can hear you.
Okay, I'll just try to talk really loudly.
Just maybe get it closer to your mouth.
Yeah, let's see if I can. Now? Alright, I'll just try to talk really loud. Okay, so before I begin, everybody get vaccinated. If you, if you don't believe the vaccine, you shouldn't believe anything I have to say, because all of the same biological and statistical principles that, were used to get the vaccine, I'm going to be using those same principles that I'm going to show you with my results. And frankly, I don't really care to talk to people who cheapen what has been my life's work. So, there's a lot of hallucinogens out there. There's, obviously there's our classic psychedelics, which that's what I'll be talking about to you mostly today. These are, these bind to a particular serotonin receptor in the brain, known as the serotonin 2A receptor. Out of the 14 serotonin receptors, it's one of the receptors that serotonin itself has the least affinity for. So psychedelics kind of act like a super serotonin at this one receptor. And so this is what I'm referring to as psychedelics. I realize like other people call other types of drugs psychedelics, but this is what I'll be referring to as psychedelics today, are these serotonergic hallucinogens. So that would be drugs like psilocybin, LSD, DMT, mescaline, etc. They're of course found in psilocybin mushrooms, as well as I just found out that bufotenine is a psychedelic that's found in a seed from the Seville tree. Anybody saw Hamilton's Pharmacopoeia? That was new information to me. There's also other hallucinogens, such as your dissociative anesthetics. These are perhaps the next most known psychedelics, or the next most known hallucinogens. They bind to a different receptor in the brain, known as the NMDA receptor. There are drugs like ketamine, PCP, dextromethorphan, which is found in cough syrup, as well as even nitrous oxide. A lot of people think that nitrous oxide just gets you high because it's depriving your brain of oxygen. No, it actually does something similar as what ketamine does. And some people have said that these are not found in nature. There is one bacteria that does actually produce nitrous oxide. Then there's your atypical dissociative hallucinogens, which I'll talk to you a little bit about today. These bind to an opioid receptor, not the same opioid receptor as heroin, but the kappa opioid receptor. So drugs like salvinorin A found in Salvia divinorum. But there's other drugs that are also kappa opioid agonists, such as anadeline or ibogaine, if anybody knows what ibogaine is. Then there's your deliriants. These are muscarinic antagonists, drugs like scopolamine and atropine, which are used in medicine for the treatment of nausea, usually not at doses that are hallucinogenic, but there are higher doses you can get that will produce hallucinations. And if you go a little bit higher than that, I think these drugs can actually also kill you, so they're not typically used recreationally. And then there's your hypnotic dissociatives. These are drugs that bind to the GABA A receptor. This is the same receptor that is modulated by drugs like alcohol, Ambien, benzodiazepines, etc. However, these drugs bind directly to where the endogenous neurotransmitter binds to. And one of these drugs would be muscimol, which maybe some of you know what that is found in the Amanita muscaria mushroom, or the fly agaric, the Alice in Wonderland mushroom, etc. So all of these drugs have, other than the dissociative anesthetics, have been used for ritualistic purposes by different native groups, and all of these drugs, other than the hypnotic dissociatives, have been used for, have shown some evidence for clinical efficacy for the treatment of depression and other psychiatric disorders. So one thing I've always wondered then is, what makes psychedelics special? Is it the case that these drugs are actually special, or are they just happen to be more fun? And hopefully I will give you some more information about that today. I probably won't answer that for you, but you can make that decision for yourself. So something that I do want to mention though is something I refer to as psychedelic myopia. There's a lot of people who think that psychedelics are particularly special, and that perhaps due to the fact that they don't research anything other than psychedelics, they haven't had a background in like experimental psychology, for example, and they probably are biased by their own personal use, and they think that certain rules don't apply to psychedelics, that you can't study them from a scientific perspective in the same way, or that laws should apply differently to them. And I want to go over a few cases of this. So I actually wanted to use the term psychedelic exceptionalism, and it turns out Carl Hart had already used this to mean when people think that, for example, psychedelics are more special than other classes of drugs, that they're maybe less harmful, they're safer, more desirable in some way, and that because of that they should be legalized, and other drugs like opioids and stimulants are, evil. It is the case that you can take a stimulant once and usually it's not going to end your life. In contrast, psychedelics, some people never come back from the trip. I'm not saying that one is more dangerous than the other. I'm just saying that we shouldn't be so exclusive about certain drugs, especially drugs that are used by particular races, white people. There's also people who will say, for example, that, that when these are actual scientists that'll say the entropic brain hypothesis proposes that the brain and mind are flip sides of the same coin. This is meant to be a model that explains psychedelic drug action. And this is actually what we all think in cognitive neuroscience. We already think this. We wouldn't be studying the brain with the idea that we can learn something about the mind if we didn't already believe this. Even the dualists out there that think that the mind and brain are separate, that study neuroscience, there's very few of them, but the few people who do, they still make that assumption that these two things are intertwined and you can't, that the brain directly produces the mind. So it's really weird that somebody has to say this acting like their model is something special. There's also people that say you can't study behavior on psychedelics, that they produce generalized disengagement. I will show you some interesting data today that actually shows that you can study people's behavior on psychedelics and that there are certain processes that might be enhanced. And then, people in the psychedelic literature, even in science, they're using these special terms like set and setting. We already had terms for that in psychology, state and context. In addition to that, people act like set and setting are so important to psychedelics when I can show you this, for example. This is a study that just came out with comparing an SSRI, so this is a typical antidepressant treatment, to psilocybin. And if anybody knows anything about SSRIs, they don't work for like a month to 2 months. They don't really work. You can see that by using the same set and setting that was used for the psychedelic therapy, you can see an improvement in people after 1 week. And if anything, I think sometimes these things are more important for drugs like SSRIs because, for example, after people start taking an SSRI, suicidality goes up. That has not been shown with psychedelics. We should be following up with people and really controlling their state and setting and everything like that in the weeks after for people on SSRIs, and do that even more so probably than we do with psychedelics, which in a lot of our, as I'll talk to you about, in our study when our patients with major depressive disorder, we follow them the day after, we talk to them many days for the following weeks, months, etc. And then lastly, a lot of people will say that the term psychedelic itself means mind revealing, mind manifesting, and they act like these drugs are superior in some way to study the mind. I will say right now that I have learned absolutely nothing about the mind from psychedelics, and I'm hopeful that one day we will learn something about the mind from psychedelics, but at the moment I haven't learned nothing, and I would challenge any of you to tell me what you've learned about psychedelics that, some underlying principle regarding the mind or brain. Yeah?
Hi, sorry, two quick questions. Could you explain what set and setting means? And also for that chart, could you explain what the y-axis means?
Sorry. So this was a treatment for major depressive disorder. This is a I forgot which they use the quids, which is just a scale of how depressed you are, showing that there's a change in depression. That after 1 week of treatment, after 1 week after psilocybin, or 1 week after taking an SSRI every day, that you get an improvement. SSRIs don't work that quickly, by the way. That's probably a massive placebo effect. but that should also tell you something about the size of the effect size for psilocybin, that there's also probably quite a large placebo effect going on as well. So set and setting, a lot of what people mean by that is your state, your mind state. So when you take the drugs, for example, you should be in a good mind state, or at least be comfortable with the people around you. And then the setting, meaning the context. So, if you're in on top of a cliff, that might be a bad thing. If you're in a really well-controlled hospital environment, that might make you feel safer and, yeah.
Could you also explain what you mean by the difference between brain and mind?
So by mind, I mean like your cognition, your what you are thinking about, etc. By brain, I mean the physical thing that I think, and I think most neuroscientists and scientists in general think, produces the mind. Those two things are directly linked. Cool. And by the way, feel free to interrupt me. This doesn't have to be like a super formal lecture or something. All right. So here's going to be the outline for my talk. So if any of you all have been following the psychedelic renaissance, there's been this whole thing about the default mode network. I'm going to be showing you that it isn't actually super special in terms of psychedelic drug action. Then I'll be talking about, I'll be addressing this thing of generalized disengagement, and actually you can study behavior on psychedelics and you can find some interesting things. And then lastly, I'll be showing you the study in which we looked at the effects of psilocybin on major depressive disorder, and we showed some cool things with cognitive and neural flexibility. So let's just begin. Okay, so just so that we're on the same page, I'm going to be talking about what's known as functional connectivity or static functional connectivity. This is the strength of association between two regions over time. So for example, you have the regions of the default mode network, and this is their activity. You can see that they track each other. So it might be the case that these different regions in the brain are kind of communicating with each other. Maybe they even have a direct connection between each other, or perhaps there's a third region that mediates the activity of these two regions. But the point is that when regions of the brain are doing this, they're together, they're oscillating together, they're probably communicating in some fashion, and they form these networks such as the default mode network. And it's, the default mode network specifically seems to be involved in self-referential processing, which has led some people to believe that this is the ego or the self. I think that's a bit absurd, considering also the default mode network is involved in a lot of things that have nothing to do with the self, including quite the opposite of the self, meaning like theory of mind, which is involved in how you think, you thinking about other people thinking, which is basically the opposite of the self, right? And so it has been shown that, from this first study and then some replications, it was shown that psilocybin and ayahuasca and LSD, they all decreased functional connectivity in the default mode network. It made the default mode network communicate less within itself. And it was also been shown with ketamine that this has happened as well. Although with ketamine, there's actually a bunch of studies that also show that you don't find that effect, as well as you can even get the opposite.
What is a default mode?
The default mode network, it's a network that's involved in self-referential processing, as well as memory, as well as future simulation, as well as thinking about what other people are thinking. So it's involved in a lot of different things, but it's a network in the brain. Cool? Does that make sense? Network in the brain that is involved in different behaviors, but specifically the people think it's involved in
the ones that aren't purposeful, like, is that why they call it default?
They call it the default mode network because it seems to be very active and especially functionally connected when you're doing nothing in the scanner. And so just by but it's also involved. It's also involved when you are doing things in the scanner, which is why it's like an absurd name.
Okay, got it.
But this is again,
so that's a scientific.
Yes, it is a scientific network.
It's not like I thought it was a Burning Man thing.
No, yeah. So what's interesting though is that there are actually larger effects outside the default mode network by psychedelics, including by the people who propose that the default mode network seems to be particularly important to psychedelic drug action. But for whatever reason, they don't pay as much attention to these other networks. And it's also worth noting that there's only been one time that people were able to associate ego dissolution with decreases in default mode network functional connectivity. There was a direct replication where they actually failed to replicate this. They tried to replicate it and they didn't. Okay. So, one last thing I have to talk about before I get into what we did with the study with salvinorin A is that there's this idea of entropy in the default mode network that might be important to psychedelic drug action. So, psychedelics are thought to break down the brain's hierarchy, and this results in all of this entropy in the brain. Entropy meaning that the brain activity becomes more unpredictable, or it cycles through more states. And in this model of psychedelic drug action, people think that the default mode network is at the top of the brain's hierarchy. So if you kind of disrupt the default mode network, the whole hierarchy falls apart and everything becomes very entropic. And it was shown that there was entropy of the default mode network. However, what these people fail to mention a lot of times is that there's actually larger effects found outside of the default mode network again. And in fact, they're found in hierarchically lower regions of the brain. So in the brain's hierarchy, a lot of people think of the brain as being like the lower areas in the hierarchy, or things like sensory areas. So for example, regions that mostly process just visual information or auditory information. And then you get into these regions of the brain as the information progresses through, that become multimodal. So they're processing both vision and audition, as well as other things like executive functions. And what's interesting is that, you do find in these hierarchically lower regions that the entropy increases are even larger than in the default mode network. So if you can't tell, I'm not really a big fan of this model. But I'm gonna, go over some things with salvinorin A. Before I do, for those of you that don't know what salvia is, I'm going to show you a little video of what it does. Let's see. Oh, I might need to connect to the internet. Shouldn't be too hard. There we go.
Oh, so just.
The mouse is so small.
Yeah, that's what happens when you unplug the TV, the white piece,
Oh, yeah.
and then you can be able to see it.
Oh,
If you unplug the big screen.
oh wait, I found it. Tiny little speck.
Yeah.
Right. There it is. Okay. So, this should give you a good example of what salvia is for those of you that don't know. Oh, wait a minute. Volume. Anybody recognize this guy? He was actually in an episode of It's Always Sunny in Philadelphia.
Hello, and welcome to Driving on Salvia. I'm Eric, your host. Now, today we're going to take the car out onto the streets, and we're going to do some K-turns, and then we're going to do some U-turns, and then we're going to go ahead and parallel park in a spot smaller than we have before. To start it all off, however, we need to take a hit of our salvia.
I think probably, yeah, my guess is, yeah, that's probably true. I mean, I think with most drugs you can, to some degree. Yeah, and he has a bunch of videos like that. Like he has gardening on salvia, and he just rolls around on the ground, you know. Yeah.
Is this the same kind of salvia the hummingbirds like?
So there's a lot of salvias. So Salvia divinorum is it's found in Mexico actually. It's used by the Mazatecs, who also used things like psilocybin mushrooms, LSAs containing seeds. Which ones are they? Morning Glory. Yeah.
Yeah.
And so they used a bunch of no, but it's in the same genus, just not the same species. Anything else? Cool. Okay.
Excuse me, is sage
Yeah.
the same thing as salvia?
So this is, what is it? Somebody might know this better than me.
That's the
This
Spanish
is,
name for sage.
yeah, so this is known as something sage, I think. That it does have that term as well. But yeah, not the same thing as all sages. Yeah. Okay. So in this study, we used a single-blind placebo-controlled study. This was we used 15 mics per kilogram of vaporized salvinorin A, which should tell you something about the potency of this drug. I think as far as I know, it's the most potent naturally occurring hallucinogen. And these were, there was this relatively small sample. This was a bit of a pilot study, and unfortunately they were all males. They were just the first people that were eligible that came in for the study. And they were all young to middle-aged, hallucinogen-experienced adults that were healthy. And so they came in for 2 sessions. In the first session, we just had them lay on a couch. We had them practice the inhalation procedure, so they would hold it in for 40 seconds. And then this is also when we made sure that they could handle the drug and not move around too much, because that would be really bad for our brain scans. And then this is also when we collected drug strength ratings. So throughout the time course of the drug effect, we'd ask them on a scale of 0 to 10, like how strong was the drug effects. If they couldn't respond, we just labeled that as a 10. And so in the second session, they came in. This is actually when we scanned their brains. And so there was always a placebo, which was just hot air, and then we gave them salvinorin A, although we told them that they could receive salvinorin A for either of those inhalations to control for expectancy effects. And then during these scans, participants just laid in the scanner with eye shades on, and there was an ambient track that just kind of played in the background. So, you're probably wondering how we got salvia into the scanner. That's me holding a bulb of salvinorin A. That little white blip is the salvinorin A, which again tells you something about the potency of this drug. And then here's that bulb attached to a vacuum adapter, which is attached to a really long tube that goes into the scanner. And then from the outside, I would then blowtorch our FDA-approved crack pipe. So, first thing I'll show you will be this, just the subjective drug strength ratings from the day before, before they were scanned, which you can see, just like what you saw in the video, in the first couple minutes, there's a very rapid increase in the subjective drug strength ratings, and then after the first couple minutes, there's a sharp drop, and then there's quite a bit of variability across our subjects. Some people were reporting being dead sober by 5 minutes. Other people were saying that there was lingering effects that persisted for 10, 20, even 30 minutes onward. So the next thing I decided to do was look at what happened to default mode networks, and that's become everyone's favorite network for some reason. And so what I'm showing you here is on the x-axis, we have, I've now split my scans into 10-minute bins, so that way I can look at what happens in the first 10 minutes and in the second 10 minutes. There's a statistical reason for this, that we get better signal if you have a longer amount of time. At the same time, it's pretty clear that the effects did not persist for most people beyond 10 minutes. On the y-axis, we have functional connectivity in the default mode network. And then in lavender is the placebo condition, in fuchsia is the salvinorin A condition. Each one of those paired points is a single subject, and what you can see is that every single subject showed a decrease in default mode network functional connectivity in the first 10 minutes. If you look at the second 10 minutes, things are a little bit all over the place. That is, some people it's looking like the default mode network remained less functionally connected. Other people it's looking like the default mode network might even have rebounded in that second 10 minutes. So what I wanted to do was see whether or not this variability in terms of the duration of effects of salvinorin A on the default mode network was related at all to the variability in terms of the subjective drug strength ratings. So for anybody who's statistically minded, all I ended up doing was I calculated a little change score. I just subtracted the second 10 minutes minus the first 10 minutes, with the idea there being that a larger change in functional connectivity would reflect those participants whose default mode network kind of came back online in the second 10 minutes. And then I correlated that with the area underneath the curve, with the idea there being that a larger area underneath the curve would reflect a longer duration of subjective drug strength ratings. And sure enough, we got a strong negative correlation. That is, those subjects whose default mode network remained less functionally connected across the whole 20-minute scan were also those subjects who reported the longest duration of subjective drug effects. So, what I just told you was static functional connectivity. So this is just saying, on average, how much are these regions in the brain communicating with each other? So it could be the case that, some people's default mode networks are kind of communicating a little bit, but then they're going off and communicating with other regions and coming back, and we wouldn't be able to capture that with a single value. So instead what I can do is I can take a measure of functional connectivity from a window of my data, and then I can slide this window down to generate a time series of functional connectivity values, and now I can do something with these values to generate what's known as dynamic functional connectivity, or I can take the entropy of, which don't worry about the math for that, but I can take the entropy of this time series to give me what I'm going to refer to as entropic functional connectivity. Now, without going into exactly what I did a little procedure, a little machine learning procedure, where I could then say, hey, which networks in the brain and which measures of functional connectivity are most predictive of whether or not someone's brain is under the effects of salvinorin A. What you can see is dynamic functional connectivity worked far better than static, and entropic functional connectivity, that's what the more color means. But what you might notice here, that's the default mode network. Default mode network was quite predictive of the effects of whether or not someone's brain was under the effects of salvinorin A. So, just to wrap this little part up, there were robust reductions in the default mode network within the first 10 minutes, and this was related to the subjective drug strength ratings. We also found, using this classification procedure, that static functional connectivity and entropy of the default mode network were predictive of the effects of salvinorin A. So, is it the case then that maybe, this whole idea of the default mode network being important is just, this applies to all hallucinogens? Well, it's also been shown with THC, that THC reduces default mode network connectivity, and so we might say, okay, well, THC is a hallucinogen. Well, it's also been shown with amphetamine and alcohol that they reduce default mode network connectivity, and those drugs are far from ego-dissolving. Those, if anything, make people more egotistical. It's also been shown with an SSRI that you can get decreases in default mode network connectivity. So, I don't think the default mode network is special to psychedelics at all. So here's the next part of my talk. I'm going to address whether or not psychedelics produces generalized disengagement, and I'm going to say that they don't, and actually show you some interesting effects on behavior. But before I do, are there any questions? Yeah.
Have you studied kratom?
I have not, but it is a mu-opioid agonist. So much like heroin, etc., except that much weaker. And I think it's really hard to OD on it because you get really nauseous. Anything else? Cool. All right. So, psychedelics have been shown on most cognitive tasks to just impair performance, which is why some people say, oh, they're just generalized disengagement, People are really banking on the fact that psychedelics enhance cognition, and a lot of times they don't. But there have been some studies showing that you can enhance some aspects of cognition. I won't go into exactly what these are, but one is semantic priming might be enhanced. Another is looking at what's known as the pop-out effect seems to be enhanced. And so the pop-out effect is, for example, I'll give you a bunch of bars that are vertically oriented, and there'll be one that's diagonally oriented a little bit. It'll pop out at you. It'll pop out even better when you're on psychedelics, apparently. At least in one study they showed that. You also shouldn't expect certain dissociations like this when if there was generalized disengagement. So there was a study that directly compared dextromethorphan, really high doses of basically Robitussin, and psilocybin, and on one set of measures, and episodic memory measures, you got massive impairments of dextromethorphan, but not very large impairments on this other aspect of cognition, working memory. In contrast, with psilocybin, you got the opposite effects. Generalized disengagement should say that psilocybin impairs performance more so than dextromethorphan across all measures, and that wasn't true. I also found that with MDMA, I realized that MDMA is not always considered a psychedelic. I will show you that in terms of memory, it does act like a psychedelic. It also does, MDMA is actually 2 drugs, and one of them does bind to the serotonin 2A receptor. The other one has the stimulant effects that we more think about of MDMA. And I showed that MDMA impaired memory, but it did so more selectively for negative and positive memories than neutral memories. So if you were going to have generalized disengagement, you should expect that there should be equal impairments across all types of stimuli, but we found that there was actually larger impairments for emotional stimuli. So before I go into what I did, I have to define a few terms. So what is episodic memory? This is the conscious re-experiencing of information from the past, or in the words of Endel Tolving, mental time travel. And when we talk about manipulating episodic memory with drugs, we have to be very careful of what phase of episodic memory that we're trying to manipulate. So for example, there's the encoding phase. This is when you're studying or learning information. So for example, all of you are encoding what I'm telling you right now. Then there's a consolidation phase in which these memories have to stabilize a bit. So you can actually kind of interfere with memories after they've been encoded, or you can strengthen them in some ways, as I'll show you in just a little bit. And then there's the retrieval phase, when you're actually remembering things, when your memory is being tested. And so drugs can differentially affect all these different phases. Like for example, THC will impair memory encoding, but if you give it during memory retrieval, people can still remember things that they encoded prior to taking THC. They just might be a little bit slower, and they also have more false memories. And so just to complicate things even further, there's different processes that we like to think about that have different neural correlates and that are associated with different states of consciousness. And so for example, there's recollection, which is the retrieval of specific details or associations from the past, like where and when information. It's kind of more typically what we think about when we talk about human memory. And then there's familiarity. This is more of a feeling of knowing in the absence of any kind of corroborating evidence. And so I realize that's not very concrete, so I'll give you an example. One day I might see some of you, like let's say at a bar, and I'm going to say, you know what, you look very familiar. I can't remember where I met you, when I met you, what your name is, etc. I just know I've met you before. That would be an example of being familiar in the absence of recollection. And then lastly, there's this idea of metamemory, so how well one understands their own memory system. So for example, there's a lot of older adults who have poor memories, and they also don't recognize they have a poor memory, in which case they would have poor metamemory. There's individuals like myself who have a terrible memory, but I've been studying memory now for 10 plus years, and so because of that, I think I probably have good metamemory. I recognize my memory impairments. And then just to complicate things again even further, there's prospective metamemory, so how well you think you will remember something, versus when you're retrieving something. Now this is retrospective metamemory, which is what I'll be talking mostly to you about today. Retrospective metamemory is after you retrieve something, how well do you understand what you're retrieving? And so essentially, how well does your confidence in your memory track your actual accuracy of your memory? So one reason I was interested in metamemory, or metacognition in general, is this idea that psychedelics are thought, the term psychedelic means mind revealing or mind manifesting. So perhaps metacognition, understanding your own cognitive processes, should be enhanced under the effects of psychedelics. So before I go into what we did, I'm going to give you just an example of how we test memory in the lab. So first, during the encoding phase, I'll show you a bunch of pictures, and I'll have you perform some task that doesn't really matter. It's just to make sure that you're paying attention, and so that under different drug effects, you're performing the same cognitive operations on these stimuli. So for example, I might ask you for a set of pictures, does this picture contain a human? In the case of my cat high on catnip, you should say no, this does not contain a human. In the case of my cat passed out on an old roommate that was passed out, you should say yes, this contains a human. And then with my cat, that is a non-human, in which case you should say no again. So then usually there's a delay. So if I've just given you a drug prior to memory encoding, I don't want the drug to affect memory retrieval. And so usually there'll be some kind of delay, like 24 hours or 48 hours later. I'll then test your memory, so that way you're going to be completely sober when your memory is being tested. And so then, let's pretend 48 hours later, I'm going to ask you, what is your confidence that you saw this picture? A 1 would be that you're certain that it's new, a 6 would be that you're certain that it's old, and then you have all the stuff in between. The probably new, guessing that it's new, guessing that it's old, probably old, etc. And so in this case, you should probably use one of the 3 buttons on the right, because this was an old picture. And I show you something like this. You did not see this picture of my cat with a bunny. You should say, probably use one of the 3 buttons on the left. And then, my cat high on catnip. Again, you should probably say, yes, I saw this, it's old. You should say old. My cat looking kind of demonically like he's burning the world down. You should say, no, you did not see that. And then me and my cat, we went to Charm Kitchen, and we used to take walks there. And you'd say, no, you did not see this. So the reason I collect your confidence ratings is using different computational models, I can then estimate these processes, recollection, familiarity, and metamemory. I don't have time to go into exactly how they work, but I'd be happy to answer any questions about them later. So in this study, what I did was I took 10 previously published data sets that had 28 total different drug manipulations, 3 different types of sedatives, a cannabinoid being THC, 2 different dissociatives, 2 different stimulants, and 2 psychedelics. And then what I did was I applied these different computational models to these data sets. And so what I'm going to show you is what happens with all these other drugs to then try to contextualize why what I think is happening with classic psychedelics is a unique effect. Yes?
With the different drugs that the same person takes? Like first you take drug number 1, then like some odd time.
Yeah. So in one of the data sets, for example, there's 4 different doses. In another data set, yeah, you're comparing a sedative to a dissociative. In another data set, it was like encoding versus retrieval drug effects. So there was a lot of, lots of different drug manipulations. But mostly what I'll be talking to you about is manipulating memory encoding, not consolidation or retrieval. Although I will go over a couple examples of what do happen during consolidation or retrieval with drugs that aren't psychedelics. So what I'm going to be showing you here are going to be distributions of parameter estimates from my model, from the models that I used. And so what you can, the top panel will always be recollection. This panel will always be what happened to familiarity. This will always be what happened to metamemory. In this particular study, alcohol was given prior to encoding, and then there was a 48-hour delay between encoding and retrieval. There was also a consolidation manipulation that was given alcohol immediately post-encoding. And so in the grade distribution will always be placebo, and anything to the left of that would be an impairment. Anything to the right of that would be an enhancement. Whenever there's a drug manipulation on memory encoding, that's always going to be the blue distribution. So you can see here, for example, alcohol impaired recollection, it impaired familiarity, and it also seemed to impair metamemory. Surprise, surprise, alcohol impairs your memory, right? But one thing I do want to point out, I realize this talk's supposed to be about psychedelics, but I always like to point this out because people don't know about this. If you notice, when alcohol was given that consolidation, that's that green distribution, you actually get an enhancement of recollection memory. This is actually known as retrograde facilitation. So, in other words, you study and you get drunk immediately afterwards. That will actually enhance your memory had you not drank at all. And it's a really insane effect that's been replicated across numerous labs around the world. It's been shown with all kinds of different stimuli, words, pictures, sentences, emotional stimuli, neutral stimuli. It's also been shown with all kinds of different sedatives, Ambien, alcohol, and benzodiazepines. I'm not going to say you should get wasted immediately after you study, you'll be hungover for your test. What I am going to say is this is a very robust effect that replicates. So that's all I want to say about that. So now here's THC. So this is THC was administered prior to encoding. There was a 48-hour delay between encoding and retrieval. You can see that THC impaired recollection, impaired familiarity. Oddly enough, it enhanced metamemory. I would love to see if this replicates. I'm still a bit skeptical of that, but maybe it makes sense. A lot of people overestimate their memory, and after taking a bunch of THC and knowing that this is going to impair your memory, perhaps you then, become more realistic about your expectations about your own memory, in which case you then get an enhancement of metamemory. Now here's a study with 3 different doses of dextromethorphan. What you can see is that MDMA, impaired recollection, enhanced familiarity, really had no impact on metamemory. That looks nothing like a stimulant to me. So is it the case maybe that because of MDMA, it does bind to the serotonin 2A receptor? Do psychedelics behave this way in terms of their effects on episodic memory? Well, here's a study with psilocybin, 3 different doses of psilocybin. We get an impairment in recollection. We start to see an enhancement of familiarity, especially at this absurdly high dose where people are barely functional, but clearly not generally disengaged, or else we wouldn't see that enhancement, and no impact on metamemory. So, psychedelic, here's an example of a psychedelic enhancing a cognitive process. Yes, please.
Could you say again the difference between recollection and
Yeah, so recollection is kind of your more explicit remembering of information from the past, like where and when information. Tomorrow I might say, hey look, I came, I was at Mushroom Fest and this guy asked about the difference between recollection and familiarity. This would be an example of, being able to recollect that information. In contrast, I might see your face one day and I might say, you know what man, you look really familiar, but I can't remember where I met you, when I met you, what your name is, etc. So actually a lot of amnesic patients, they can still perform above chance on a recognition memory test because they still have familiarity, but they don't have recollection. Yeah?
Is that something where, if your recollection goes up, are they exclusive? Or, can you be, what's your recollection really high? Does familiarity not matter?
So this is actually, it's actually kind of interesting that you say that. So a lot of people haven't totally bought the dual process idea of memory. Because a lot of when you enhance recollection, you do see at least a numerical enhancement of familiarity. And as I just showed you with all those drug effects, whenever there's an impairment of recollection, there was at least a numerical impairment of familiarity. That's what was so cool about this. This is, I think, evidence for this idea that these two things are separable. That you get an impairment in one process and at least a numerical enhancement of the other process. So yeah, they can decouple actually. And I will actually go over a couple examples.
You
Yeah.
said a high dose where they were hardly functioning. What kind of dose?
So it was 30 milligrams per 70 kilograms, which is something along the lines of 5 to 7 grams of mushrooms, maybe. So, say what?
Hero dose.
Yeah. So I think, for those who don't know, most people usually take maybe, 2 grams or something when they're doing magic mushrooms. In this case, yeah, we're talking 3 times that amount probably. And so, yeah, it's quite interesting that there was an enhancement of the cognitive process. But I should also mention, yeah, I guess there are situations, so for example, like I said, with amnesia, they do have, a lot of times they will have familiarity. There are situations though, for example, like Capgras syndrome might be an example of where recollection's there. For example, you think that you know somebody, and you're like, this looks exactly like somebody I know, but the familiarity is not there. They don't feel familiar, and because of that, you're like, you're an imposter. This is actually a real syndrome, Capgras syndrome. Look into it. And so that might be an example of recollection succeeds, but familiarity fails. So, as I just mentioned, it's kind of interesting that these three drugs, sedatives, dissociatives, and cannabinoids, they impaired recollection and familiarity, at least at higher doses, but psychedelics impaired recollection and spared or perhaps even enhanced this familiarity process. And there are situations in the lab that don't involve drugs in which you can kind of manipulate recollection to be low and familiarity can be high. And in those situations, you'll get people reporting that they feel deja vu, or feeling like they're about to have an insight even when they don't actually have an insight, or that they can predict the future. If that doesn't sound like somebody on psychedelics to you, I don't know what does. And we did not find, although the term means mind-revealing, psychedelics, we did not find that psychedelics enhanced metamemory. There's only one aspect of metacognition. Perhaps we were look at prospective metamemory, which is something that we do plan on looking at, that maybe then we'll see an enhancement, or perhaps some other aspect of metacognition, such as how well, like perception, metacognition of perception. Maybe those would be enhanced. Cool, so I'm gonna now move on to the next part of my talk, but before I do, does anybody have any questions about that? Cool, all right. So, now we're jumping into what psychedelics are doing after the trip is over, in terms of brain function and cognition, and specifically in patients with major depressive disorder. So before I get into this, we should talk about this new sort of construct that I'm going to introduce to you, cognitive flexibility. This is how well one can adaptively switch between different cognitive operations in the context of a changing environment. So to give you an example of how this is measured, the most common way it's measured is a Wisconsin card sorting task. So you have these 4 cards up here, and I give you this card, and I say, which card does, where does this one match? Which one is this related to? Let's pretend you choose that because they're all the same color. You choose C, and I tell you, no, that's wrong. And then later on, you choose B, and I'm like, that's correct. So the rule here is that it's about number, the number of items on this thing. After several trials of this, I'm now going to switch the rule on you without you knowing, and then I'm going to tell you, nope, you're wrong now. And so when that happens, you should now try to figure out, well, what's the new rule, right? And what people will show with patients with major depressive disorder, with addiction, with OCD, etc., there's actually an impairment in cognitive flexibility. They will perseverate on the old rule even when it's no longer adaptive. And so it's actually been shown that there's a region in the brain known as the anterior cingulate, and that neural flexibility of this region seems to be involved in cognitive flexibility, although I want to say that neural flexibility or variability in brain activity does not necessarily mean cognitive flexibility. There are extremely variable brains that are not adaptive for cognitive flexibility, such as in patients with schizophrenia. But in general, more flexibility in the brain's activity can mean some flexibility in terms of behavior. And as I told you earlier, psychedelics have been shown to increase measures of neural flexibility, in this case entropy, acutely, but it's unclear what happens after, like, let's say a week after you take psychedelics. Is there still increases in the brain's variability or flexibility? So we decided to test this in patients with major depressive disorder. In this study, we had 2 groups of patients with depression, one that received psilocybin therapy immediately, and another one that had to wait for a little bit of time, with the idea being 8 weeks specifically, with the idea being that just by interacting with our group, do they get better, or is it really the psychedelics that are, treating them? And they took 2 doses of psilocybin, a moderately high dose and a really high dose that were separated by about a week and a half. We scanned their brain 1 week before they received their first dose and 1 week after they received their second dose. And we had about 20 subjects. These were all young to middle-aged adults with major depressive disorder that had limited hallucinogen use. So the first thing I'll show you, this has actually been published, although they did not show single subject data, so you're getting to see this. This is what happens to just their depression. So everybody that's before this baseline, those are the people that had to wait before they received their therapy. You can see that their depression did not get better just by interacting with our group. But after baseline, this is when they received psilocybin therapy, massive improvements in their depression, such that some of these people are no longer clinically depressed. And this lasted for about a month. And I can tell you that for some people it even lasted 3 months, although a lot of people did return to their medications and did become depressed again after 3 months. That'll hopefully be published soon. You look at where?
Yeah, what journal?
I have no idea. I'm not actually on that paper. I just do brain stuff. Right? So But how about cognitive flexibility? So again, what we're measuring in cognitive flexibility, really what we're measuring is cognitive inflexibility, so that the number, what we're measuring is the number of errors that they're making on this task. More errors means less cognitive flexibility. So what you want to see is things going down, just like with depression. We want to see that going down. What you can see is that everybody who was in that group that had to wait, so they performed this task twice, they didn't get better at this task. So it's not just that they performed the task twice and they got better at it. They did not get better until after they received psilocybin. You can see that now they're making less errors on this task. So their cognitive flexibility improved. So I then decided to look at the ACC, the anterior cingulate cortex. It's involved in cognitive flexibility. And then there's the posterior cingulate cortex, which seems to be very involved with psychedelic drug action. I then wanted to look at the functional connectivity between these two regions, because people had shown one day after ayahuasca, you can get increased functional connectivity. Regular functional connectivity, nothing changed. However, dynamic functional connectivity, this measure of neural flexibility, did get enhanced under the effects of 1 week after psychedelic treatment. So then I looked at the correlation between, does this relate at all to those improvements in cognitive flexibility? And sure enough, we did get that there was a correlation now between those increases in dynamic functional connectivity and those decreases in errors on that task that measures cognitive flexibility. But for any of you that are statistically minded, there's something weird here. This is a positive correlation. Usually when you have one measure that goes down and one measure that goes up, you should expect a negative correlation. That is, the greater dynamics should predict less errors on a task. Instead, what we're getting here is that the greater increases in dynamics are producing less improvements in cognitive flexibility. So what's going on here? Well, I did this really complicated modeling procedure that I'm not going to go into, but I'll just try to explain it to you in this little, what's known as an inverted U-curve. So, just like with something like stress, a little bit of stress can help you get some work done, but too much stress is going to make you terrible, right? There's kind of there's a perfect sweet spot of having the right amount of stress to get work done. Similarly, that might be happening here with neural flexibility and cognitive flexibility. So let's pretend you're depressed. You start off right here. You don't have a lot of neural flexibility. You have a really rigid brain, and you also don't have very high cognitive flexibility. I give you psilocybin therapy, and your neural flexibility now increases, and guess what? Your cognitive flexibility gets a massive improvement as well. Let's pretend you start off over here, though. And then I give you psilocybin therapy, neural flexibility increases. You only see a small improvement in cognitive flexibility because you're on the other side of this inverted U-curve. Now let's pretend you start off right here. You have very high neural flexibility and pretty high cognitive flexibility already. I give you psilocybin therapy, neural flexibility increases. Well, now your cognitive flexibility might actually decrease in this situation. I haven't been able to prove this, but we are doing a study with a lot more participants where hopefully I can map out this full inverted U-curve. So, psilocybin therapy did improve depression and cognitive flexibility. It also increased neural flexibility of the dynamics between the anterior cingulate cortex and the posterior cingulate cortex. However, those greater changes in neural flexibility were actually associated with less improvements in cognitive flexibility. And then, I didn't show you this, but basically I showed that people who started off at baseline with high amounts of neural flexibility were also those who had the least amount of improvements in cognitive flexibility. So, it might be the case that too much neural flexibility is detrimental to the improvements in cognitive flexibility, which again shouldn't surprise you. As I mentioned, patients with schizophrenia have a lot of neural flexibility and they're not exactly, they don't perform well in these cognitive flexibility tasks. But it might also be the case that there needs to be some high amount of neural flexibility at some point, like while you're on the drug, and that during this time, this is maybe when we should be like giving you certain types of therapy or showing you certain types of stimuli to try to maybe, let's say, change the way you think about certain aspects of your life, or maybe change the way you're representing certain memories, etc. And so, just to go back to my question, are psychedelics special? Well, in terms of their effects on functional connectivity, it does not appear that they are special. And in fact, there's no evidence that I can find so far that there's idiosyncratic effects of psychedelics in the default mode network. Regardless of what Michael Pollan's book said, this is not special to psychedelic drugs. In terms of their effects on episodic memory, there did seem to be some kind of unique effects of psychedelics compared to various other drugs. They impaired recollection while sparing or even enhancing familiarity. Now, in terms of their effects on major depressive disorder, it is the case that other treatments can increase cognitive and neural flexibility, but this is really promising that 2 doses of psilocybin can have a long-lasting, well, maybe not long-lasting, but at least a 1-week effect in terms of improvements on cognitive and neural flexibility. So I'm hopeful that maybe there is something unique about psychedelics in terms of their treatment for major depressive disorder. So, I just want to say thanks to my lab, thanks to my collaborators, thanks to the participants, thanks to our funders, and if you don't already, please follow me on Twitter. That's it.
Thank you.
Thank you.
Yeah.
Idiosyncratic effects on.
Wait,
Go over what idiosyncratic.
idiosyncratic, meaning like kind of special effects that are really kind of weird and unique to psychedelics. So that is something that we're not seeing, at least in terms of the effect on the default mode network, as far as I can tell. But yes, wait, you had a question?
Yeah, can you like
Oh,
backward slide?
yeah. Cool.
That's very good.
Thank you. Yeah, you got a question?
You say like persistent enhancements of the potential improvements in depression. Was it ever dosed more than once? Like you could dose like depression, you said like might creep back up and then
No, so we didn't do that. So I mean, they got 2 doses, and then it was we looked at depression. We've been following those people for the last I think it's been over a year now. And yeah, a lot of people's depression did relapse by about 3 months in. And I think at 1 year, I'm sure most people, I haven't seen those data, but I'm pretty sure most people are probably not. Yeah, they're gonna have to get redosed probably. I think that the way this drug will work will be a lot like ketamine. Maybe it'll have longer lasting effects. When ketamine started, people were showing, the initial studies were showing that, oh hey, this lasts for like 3 months. And then it was like, as more studies came out, I was like, it only lasts 1 month. And then it's like, it lasts about a week. I'm hopeful that psychedelics will have a longer lasting effect, but it wouldn't surprise me if, you have to take it once every couple months. But I mean, that's, 6 pills a year rather than 365? So, I don't know, yeah.
As I was thinking about the different slides you showed, would you say that the thesis of your research was that inverse U-curve?
I don't know if I would say that specifically.
That's your conclusion. Is your conclusion?
That was for at least the effects on major depressive disorder, in terms of, or at least in terms of cognitive and neural flexibility, the relationship between those two. I think one of the things that I do is, just really trying to find what makes these drugs unique, and then if we can find what makes them unique compared to other drugs or other kind of manipulations, psychological manipulations, we can hopefully harness that and improve treatment, or at least minimize the harms of these drugs, because these drugs aren't totally harmless. Like, I don't want anybody to go home and take a bunch of psychedelics, But yeah, I think that just by finding what makes these drugs very unique, hopefully we'll be able to enhance treatment with them. As well as maybe we might even learn something about the mind.
But it sounds like you have to have a really well-established baseline.
What do you mean?
Like, because especially when you were comparing the people with major depressive with people who have less flexibility, comparing them to people who have more flexibility.
Right.
So so your control group. So like really knowing what your control group is.
Yeah. And I mean, I think one thing that I was sort of showing is basically if you can know where somebody starts in terms of neural flexibility, maybe you might be able to show the people that can, for example, benefit more from this type of treatment. Like, I don't think that everybody's going to benefit from psilocybin therapy. I mean, I showed you there were some people in that in that figure that didn't get much of an improvement. But I think it's going to be one more treatment, just like, SSRIs, ketamine, brain stimulation, etc. It'll be one more treatment that we have, and I don't know, maybe it'll be a paradigm shift, but I'm slightly skeptical of that.
Other thing, you pointed out one of those things you talked about people being neurotypical and also characterized as healthy. So that means that you didn't have people who are non-neurotypical.
Yeah, so in a lot of our studies, so in just looking at the basic effects, we do try to find people that are neurotypical, healthy adults that don't have, any psychiatric issues. Yeah, in terms of major depressive, those are not neurotypical if you have major depressive disorder.
Right.
And so that was a totally different study. But yeah, we do healthy studies. We do different types of patients. Currently, there's a study going on with anorexia. There's a study. There's a depression study again. There's a PTSD study that will be started. They're looking at treatment of depression with people with Lyme disease, I think. There's all kinds of things that people are looking into. I'm a bit skeptical I don't think these things are going to help everything, but I imagine they'll help at least depression.
What about memory?
Memory. There is an Alzheimer's study that they're doing, but they're really using it to try to treat depression. So there has been some research showing that the problem with something like Alzheimer's, like neurodegenerative disorders, is when the brain's damaged, it's good luck. There has been some studies showing that psychedelics can kind of increase certain aspects. They might regrow some neurons in certain regions of the brain, a very specific region of the brain, but they might increase some types of structures in the brain. They might enhance those. In which case then you might say that, hey, these might improve memory in patients with like Alzheimer's, but I'm doubtful. The kind of deterioration you get in Alzheimer's is nothing's gonna, I hate to say that, but yeah, when things go really downhill, good luck with something that's gonna like increase the number of neurons or connections to a degree that's gonna give you your memory again. And the other thing is that with something like familiarity in the absence of recollection is, although I refer to that as a cognitive enhancement, it's not really an enhancement per se. You can actually, weird things can happen, like I mentioned, like deja vu, or thinking you can predict the future, or false memories can happen under those conditions because you don't have recollection to control that familiarity. So, yeah, I don't know if they'll enhance memory, but that is something we are planning on testing, is looking at 1 week after psilocybin therapy, will we see that people's memories do get better? And patients with major depressive disorder do have impaired memories, so I don't know, maybe by treating their depression, their memory does get better. You had a question first, I think, yeah.
So I'm just curious how, like, talking about the impaired recall and enhanced familiarity might play into treating PTSD, and then also how PTSD would be linked to depression, and how you sort of tease out those confounding factors of somebody, you know, somebody who's sort of, I'm speaking broadly, like someone who's more just like chemically bipolar versus someone who's got more of a situational element to their depression, where maybe, you know, that moment of increasing familiarity and reducing recall sort of quote unquote snaps them out of something and gives them a couple days of like less traumatic experience, if that makes sense.
So one thing about familiarity is that it's represented by regions in the brain that really slowly sort of learn. And so you have these memories that become very ingrained, that it comes over time. So for example, if I take out, there's a region of your brain, the hippocampus, that's involved in recollection. If anybody's seen the movie Memento, it's based on a patient who had his hippocampus taken out. And you know, recollection, the hippocampus is a very fast learner. And then in contrast, your cortex is a slower learner, and that's where familiarity seems to be represented. And so my thinking is that, so for example, if you take out my hippocampus, I'll probably still remember my mom, you know? I'll still remember her. She's been, you know, her memory has been consolidated and it's very crystallized in my brain, you know? Patients with Alzheimer's, a lot of times, actually the first thing that does start to go is familiarity, but then recollections massively hit, and then they start to lose all the, you know, familiarity as well as all these kind of crystallized memories, like, you know, they can't recognize their parents anymore, etc. But, so one of the things that I've, you know, this is totally speculating, you know, but is that maybe by enhancing familiarity and enhancing memories that are encoded through these regions that don't learn as easily, that we can kind of change some of these kind of crystallized patterns and memories that we have in our head, like in PTSD. They become very sort of crystallized, become a part of who you are, even if they're not even accurate anymore, you know? PTSD actually has a lot of distortions in their memory. And even with depression, you know, your sense of self can just, you know, it's very, you might just be very, you know, self-degrading, whatever, and that perhaps you can alter that by enhancing, you know, familiarity-based memories in the cortex. But again, this is totally speculating, you know, so yeah.
I guess I'm just wondering if that sort of bridges the gap between like, hey, maybe this works similar to some of these other drugs, and this sort of like woo-woo, like it solves everything, just take it, it's magical divide, you know what I mean? Because you're sort of addressing that sort of more subjective
mechanistic
experience, yeah, that more sort of subjective opinion that a lot of people have about how effective psychedelics are, you know.
Yeah, I mean, I
based
think
on their personal experience.
Yeah, you know, but I mean, I think the subjective experience is rooted in a mechanism of the brain,
right,
you know.
right,
yeah, as I said, you know, I don't think those two things are separable. And I realize, you know, if anybody's religious or dualist or whatever, that's controversial, but most scientists don't think that way. So yeah, I think you had your hand up first, yeah.
I was just curious if you followed up with any of those major depression studies more than a week. If you were continuing to do tests to see if the effects go longer or if they diminish over time.
Yeah, so the cognitive flexibility did seem to, we only did that up to 1 month. That did remain enhanced. There is a problem here though, known as practice effects. If you perform a task more than once, you'll get better at it. And that's what we showed, is that people didn't get better before they received psilocybin therapy, but afterwards they did. You wouldn't expect them to get worse after performing that task, you know, a couple times already, and they got better at it. With other aspects of cognition, like memory, I think we can totally do that and see whether or not that persists for longer than a week. I don't think we're going to be doing that in a study that's coming up. But, you know, yeah, it's worth looking at to see if any of these things, yeah, do remain. So even if their depression gets bad again, at least do they have enhancements in cognition? Because it is a problem, actually. A lot of our antidepressant treatments, they can improve, you know, they can improve your mood, but they don't always improve cognition, you know, and there are impairments in cognition across most psychiatric disorders. So it would be great if we could also enhance those. Yeah.
Yeah, so a lot there's a ton of examples of studies on augmentation therapy in the major depressive disorder literature, like combining an SSRI with recosapine, that kind of thing. So when do you think we can get to see like ketamine co-administered with psilocybin?
I don't know, but I'd love to do that. Or brain stimulation, TMS, so transcranial magnetic stimulation. People have shown that that combined with ketamine might be more effective than ketamine alone. There's only one group that's done it. But, you know, I think, yeah, combining things. There is a study in Ireland, I think, that they're going to do looking at patients on SSRIs and giving them psilocybin. There is something to be said about that, and we've actually seen in our lab that people are off of SSRIs, but if they were on the ones that had really long lasting, like a really long half-life, like Prozac, like that takes a long time to get out of your system. Even though it's supposed to be out of their system, they actually show less of a response a lot of times to psilocybin, and that's certainly the case that a lot of people that take antidepressants, when they take a psychedelic, they don't get a very large effect. And there's a reason for that, that you get a downregulation of the serotonin 2A receptor when you take SSRIs. And so the thing is that, you know, when anything binds to the serotonin 2A receptor, it'll actually get internalized into the neuron. And serotonin itself doesn't have very high affinity for the serotonin 2A receptor, but if you flood the brain with a bunch of serotonin by giving them an SSRI, or at least flood your synapses, then you'll get more binding to the serotonin 2A receptor, and then it'll be downregulated. So, you know, there are people who are taking, I think there were some patients in the anorexia study that they're getting these really high doses, and they did not get a very large effect. I think they might have increased the dose, but I'm not doing that study, so I can't speak on that. But yeah, so I don't know when they're going to be combining things, and I mean, with everything, you know, like ketamine and psilocybin. They are doing a study looking at giving people midazolam, which is a benzodiazepine, while people are on psilocybin, with the idea being that knock out their memory from midazolam. And if you can't remember anything, do you still get the improvements? If you can't remember the mystical experience, do you still get an enhancement of, you know, improvements in your depression? And I think that's a really cool idea. And I think that to some degree you probably will see some improvement in depression, but maybe you do need to be somewhat aware of what's going on to get the maximum benefit.
Aware of what you're experiencing. I mean, I guess maybe for some people though, they could really benefit from tapping out.
Right, I think so. I don't know. I mean, some people have terrible experiences. Like here's something that's worth mentioning is that these patients with major depressive disorder, they go through a lot of hell sometimes when they're on these absurdly high doses.
Right.
Yet they do get better, you know? And I don't know if it's always the case that you really do need to go through hell to get better.
Right.
But I don't know, maybe it's true. Yeah, and so...
How can you make that judgment?
Yeah, I mean, if I were super depressed, I would rather not go through hell to get better, but, you know, yeah.
Do you think there's sort of a common pathway between, I mean, obviously like neurogenesis is cited as like the final common pathway, but like a lot of people talk about this like AMPA-mTOR pathway with ketamine.
Right, and so that's
similar and
yeah, so it's thought to increase plasticity. So neurogenesis is not totally always shown to, it's kind of controversial whether or not, there's only one region of the brain, actually the hippocampus, which I mentioned, which is involved in recollection. It's the only region of the brain that you really see neurogenesis. And actually some people argue in humans you might not even get that at all. It's still kind of controversial, at least adult humans. But in some animal studies they have shown that, yeah, psilocybin and DMT can enhance neurogenesis, but the bigger thing now is more about plasticity. So it's what's going on at the synapses. So you have different neurons. You have a neuron that's connecting to this neuron. And when this neuron fires, it'll increase the probability that this one will fire, but it doesn't necessarily mean that this will fire. By enhancing plasticity, you might now even better enhance that probability that this other neuron will fire when this one fires. And so by increasing dendritic spines, the morphology of them, by increasing the numbers of them, etc. And so I think that there's some evidence that, yeah, ketamine does that, and the psilocybin is doing that, and that might be involved in this enhancement, but this improvement in depression. But I mean, too much plasticity isn't a good thing either, you know?
Yeah, I was curious about, I don't know if you've heard of it, there's the mammalian target of rapamycin thing.
No, I don't.
Oh, okay, so it's sort of been, so scopolamine, which does sometimes have antidepressant, has been shown to have
the same people that were doing the ketamine studies first actually also found scopolamine did also produce antidepressant effects.
So both of those have been shown through this they both do this similar activation of, it's thought to be through like AMPA receptors, there's this elevation in the mammalian target of rapamycin, which is thing.
Okay, well, I mean, you get an increase in AMPA receptors when there's so LTP, long-term potentiation, that's that increasing of the coupling between neurons. The way that happens, the final mechanism is that you get an increase in a number of AMPA receptors. But it involves the NMDA receptor, which is actually really weird that ketamine actually blocks the NMDA receptor, and yet it then has these weird neuroplastic effects, at least subsequently. Any other questions? Yeah, please.
Do you have any ideas whether it would help with OCD? Have any effects on that?
Yeah, there's a study that I think it was right when the center was announced. So I don't know if y'all heard, there was like 17 million that was given by a bunch of donors. It was like immediately after. I swear it was like almost like a week or something after. Somebody contacted the center and wanted to do an OCD study. So we are doing an OCD study. There's already a couple OCD studies, one that's been done and two that are in the process. One at Yale. Yeah, I mean, I would, it might help that. I'm a little skeptical of some of these things. The psychedelics just improving absolutely everything. I think that, we'll see what happens when the more rigorous clinical trials. There is a massive bias in this literature that people really think that, and if the experimenter thinks that you're going to get better, there's a higher likelihood that you will get better. Which tells you something about, are these just super placebo effects? I don't know, but I think there might actually be something there, at least for depression. Maybe with OCD, it breaks the cycle of. There is a circuit in the brain that is involved in psychedelic drug action that also is involved in OCD, and maybe it's the case that it kind of breaks that circuit a little bit, so that you're not kind of going to these habits. But yeah, we'll see. Yeah.
Doesn't that make sense to say if you're doing a psychedelic or something that you're using all the different parts of your brain, so it's going to create neural pathways, just like
I wouldn't say that you're using all parts of your brains you always use your brain. It's different.
Just for the record, I did 90 days of microdose for PTSD, and it was really good.
Yeah. I mean, I'm sure people are talking about all kinds of things.
It broke my waking up in the morning. It broke me thinking about the event.
Yeah, I mean, yeah. Well,
it lasted for a while, but after like a month and a half after I was done, it started to look
microdosing thus far in clinical trials has not really shown enhancements in cognition. I will say that. Actually, I might even have a slide on that. Can't remember. But there's several studies that have been done, and they're not really showing much enhancements in cognition. It is true that your mood gets better. Low doses of psychedelics, it wakes you up a little bit.
I got my memory like 10 times better also. This was before I got like my injuries, but I don't know what I did. It was red light therapy, wind hop, or taking that syringe and stuff. But like I could only remember like 3 numbers for like 20, 30 years, and then all of a sudden I could remember 10. And I went and learned algebra. Like I don't even know what happened. I was meditating too.
Yeah, I mean,
really grew my brain.
Yeah, we'll see. There are clinical trials that are being done, I think, with microdosing for the treatment of major depressive disorder. I think. I'll be curious. I mean, just like an SSRI, they do mess with the serotonergic system. So it wouldn't totally surprise me if you got some enhancement or improvement. But I'm not going to be the first person to microdose for 90 days. I'm
I wasn't depressed.
Yeah. Yeah.
For your clinical trials, on average, are those subjects just still depressed and just untreated and unmedicated, or is there like a subset of people who are being off the medication?
So I can't remember with this particular study with major depressive disorder, but this study, they had to get off their medication if they were on anything. And I think they have to have tried at least 2 different treatments, I think. It might even been more. It's published in JAMA Psychiatry, you can find that information. I just analyzed the brain data. But there is some requirement that you've tried some other therapies. That's not just somebody who's freshly depressed. And so yeah.
So it's not someone who's just completely untreated.
Well, they are in the sense that they can be untreated now that they're not taking their meds anymore, and that condition of some sort. That way, it's somebody to monitor them in addition to us, But I think that was probably necessary, and it definitely was the case that if they were on meds, that they were to taper off with the help of their psychiatrist, not just like, hey, just get off your drugs and then we'll give you some mushrooms, right? It wasn't like that. So it's a very controlled sort of situation. Yeah.
How do you feel about, I think, it's been a while since I looked it up, but I know there are organizations who kind of do ayahuasca retreats, and protect it as, I guess, a religious group? And
Yeah, I'm actually, I think, on the scientific advisory board of this thing that's almost like Yelp, which, you know, of those legal retreats around the world, like in the Netherlands, or yeah, I think there's some in Brazil and Jamaica, etc. I mean, there's a reason I wanted to get on that scientific advisory board, is that I think that in some of these situations they can potentially, I don't think they're always doing good. There's definitely some shamans out there that are, not doing good things, that can be abusive and whatnot. So, I think it'd be good. I think it's good to have, for example, Yelp ratings say, hey, look, this place is terrible, don't go to it, But there are people who swear by it, and I don't think there's anything special about what goes on in a jungle when somebody's speaking some language you don't understand. And for that matter, ayahuasca, like, I would rather take what's known as pharmahuasca. I'd rather take DMT plus a monoamine oxidase inhibitor, that way you're not throwing up and, pooping yourself. I would much rather do that than, and here's the thing, for example, in our study with psilocybin, we're giving people absurdly high doses, and they don't end up getting, some people get a little nauseous, but they don't really throw up. Some people don't even experience any nausea, even on these absurdly high doses. The mushroom itself is not very good. Like, I know I'm at a mushroom festival, and I probably shouldn't say that, but I would much rather take synthetic psilocybin than, all the garbage that's in the mushrooms. Synthetic. Yeah, it's been synthesized in the lab. Yeah. And so, the one good thing about the mushroom is that you can easily produce it. You can easily produce psilocybin, but it contains all this stuff that's not even, that, binds to things in your gut that makes you sick and want to throw up.
That's part of the experiment.
But it's not, though, because people got way better in our study and they didn't experience nausea, I don't think the nausea is necessary. That's absurd. And if it were necessary, then we can give them pure psilocybin and ipecac, Yeah, I'm extremely doubtful that nausea is necessary to the therapeutic efficacy of psychedelics. And I think anybody that thinks that is, making a massive fallacy, what is it, the natural fallacy, where anything that's natural is better. It's like, all right, eat some poison dart frog and tell me that. Yeah. No, it's created in a lab. So I think in this study, it might have been Dave Nichols who gave it to us, but there's this group called USONA. They're the ones that are giving us psilocybin now. So they just created it in a lab. A bunch of chemistry that I don't fully understand. Yeah, I'm not a chemist. Any other questions? Yeah, please.
If you could pick 3 studies to do that aren't being done and haven't been done, what would you want to study on psilocybin? Or what do you think would be the best impact?
So I have a bunch of very neuroscience, experimental psychology specific questions that would probably be boring to people here. But at least one of them that I do think would be interesting would be, actually, so people just lay on a couch with eye shades on when we do these studies. They're told to just kind of go inward, and of course, if they freak out, there's clinicians in the room, and they're told to calm down. But generally, they're told to just lay there and just allow things to work. The inner healer. I don't really buy this inner healer thing. I think that what you probably should be doing is doing some kind of therapy or queuing up their memories, for example, showing them pictures of things that maybe are for example, that are traumatic, and making them sort of think of those things in a way that's less maladaptive. Basically, like exposure therapy, which is what people do with PTSD already. But maybe doing it under the influence of psilocybin might have an even larger effect. Maybe. That's something that I would really like to test. The other thing that I didn't mention, this is the thing that gets really, this is probably going to be a little boring, is that the computational mechanisms underlying recollection and familiarity are different. One is thought to be a threshold, kind of an all or none process. You either have it or you don't. That's recollection. Whereas familiarity is more this kind of graded feeling of, there's an infinite number of states that you can have, strengths of familiarity. And so there's other sort of strength versus threshold-based processes in the brain, like in perception. And I would like to see if maybe all the strength-based ones, or kind of the continuous processing of information, is maybe enhanced by psychedelics versus the kind of threshold heuristics, which might be impaired by psychedelics. That's something that I'd like to do. Yeah. 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 Yeah, so I actually don't know. I don't know if there has been a Deja Vu study that's been scanned, though, that has been actually scanned. What I can say, though, is that I did mention the whole Deja Vu thing, where they actually manipulated. They found situations in which your recollection was low and familiarity was high. The way they did this, actually, was using a virtual reality paradigm. They walk you through, like, let's say, a graveyard, and then later on, they walk you through virtual. So They walk you through a graveyard, virtual reality, and then later on they walk you through something that has an identical layout, except that it's a conceptually a different space. Like, for example, like a junkyard instead of a graveyard. And so it's got all the same sort of, like, instead of being a tombstone here, now you've got like a piece of junk, you know? And then over here, and then you go through the same path that you walk through. You're sort of walked through this virtual reality thing, you don't get to control it. So you take the exact same path, and then they ask you, they stop you somewhere, and they're like, are you going to turn left or right? And if you had recollection, you would then know that, oh, I would be turning left here. You fail, your recollection fails, you're not able to perform that task very well, and yet you will then report in that situation, but there's high deja vu. So that familiarity being high, the layout was very, you know, the familiarity of the layout was very high, but your recollection failed. And people report deja vu and feelings of premonition, etc. So I think that there's some similarities. I don't think that those two things necessarily are totally the same. But I don't know, yeah. I think that there's something there, probably.
Mm-hmm. Has there been any studies done that you know of with like teenagers with depression or anxiety or anything like that? Like
with psychedelics?
Yeah.
No. I honestly don't think kids should take psychedelics. I don't think that, you know, if there's anything we know about cannabis, this idea of cannabis and schizophrenia, the link is somewhat tenuous. But if there's anything we know is that you shouldn't be using it at a young age, and that is going to increase your likelihood of cognitive impairment that's not just temporary or, you know, schizophrenia. And, you know, it is the case that, yeah, like, you do hear about the 20-year-old that tried psilocybin for the first time and they never came back. I've never heard of a situation of a 60-year-old trying psilocybin and never coming back. I have heard of a situation of a 40-year-old, but I think they already had other issues previously. And so, yeah, I don't know if kids should be doing it. I mean, maybe if there's nothing better, if nothing else works.
I heard that, like, the FDA, I think, was like, why are you discriminating? Like, you know, if this is safe for, like, older people, it would be safe for younger people.
I mean, I think there's a lot of it. So you have less connections in your brain as you get older. And that's not a bad thing. It increases efficiency. More connections is not necessarily a good thing. And so I think there's just less likelihood for probably something going wrong if, you know, yeah, you're under, I mean, honestly, yeah, there's not a lot of data on this. I can say that I have two friends that never quite came back after taking, you know, psychedelics. And like one of them's on, she'll be on medication for the rest of her life. The other one, he's turned into one of those QAnon people. Yeah, and so, and when I say QAnon, he's actually also clinically diagnosed and crazy. Yeah, I mean, I shouldn't say crazy, that's a bad word. Yeah.
With your question, are you concerned about pharmaceuticals or as well? And I mean, even from your perspective, like, should we be more concerned? Like you kind of mentioned it earlier with the stimulants with the children. Like, I work in pharmacy, actually at Hopkins, and I see, you know, 4-year-olds, 5-year-olds, like, you know, and even like the 12, 13, 14, like they're still developing and we're giving them like SSRIs, and like I find it scary, and maybe it helps to a certain extent, but I think you're right, like children, like do we really want to be bombarding their brains like as they're developing? That's just like a person.
Yeah, giving kids.
Like it's be screened really well and stuff like that.
But it's not. You know what I mean?
Yeah.
Like, where is it? It's like actually screened really well. You know what I mean?
Yeah.
No, I don't think it's good.
Yeah, I'm not a fan of, I mean, I think there really are kids that do need stimulants, that need amphetamine.
And
I think it's
that,
really
right?
rare though, you know? I think it's in this country
It's
we have,
overprescribed.
yeah, I think it's much higher than Europe in terms of like the rates of prescription, like 10 times or something or more.
Schools are set up,
Yeah.
I'm sorry to go on like a tangent, but the way that schools are set up, like it's not really conducive for learning for children who need to be active, like, you know, they are here, for instance, and so yeah, like you're drugging them to create a mindset that is suitable for what? Like, not creativity. Not really.
You know, I think it depends. I don't know. I mean, creativity is a hard thing to define, but I wouldn't say that, you know, I mean, look, there's been some brilliant mathematicians and musicians that created their music on stimulants, you know?
Yeah, but were they like 12?
That's,
Maybe.
yeah, maybe not. Yeah, I don't know. Yeah, but exactly. Like, I mean, too much stimulants. I mean, it's totally true that, yeah, the amphetamine psychosis is a thing. It's nearly indistinguishable from schizophrenia.
Right.
So, you know, you take really high doses of amphetamines over long periods of time, you can get people to go pretty crazy. Yeah, and I hesitate. You know, I would hesitate to give kids, stimulants. But I'm not saying that. I think some people definitely need it.
The research is being done on children. I mean, in some ways, I don't know about psychedelics, but with drugs, you know, like it does happen. It does happen.
Yeah, and so I don't know. Yeah, you know, I remember talking to a friend, which, you know, am I still being recorded? Oh,